Alrighty then, corn children, children of the corn, it is a fine day for mathematics. We're going to be looking at more on transformations, meaning we've already done some in the past. We're going to look at it specifically as a concept of composition, which we've also looked at in the past, and specifically with piecewise functions, which we have also looked at in the past. Whew, it's a lot of past. All right, so here's what I want you to do. I'd like you to consider the function f of x equals x squared minus x minus 2 with me. Now, because I have a graphing calculator, yeah, I do. I typed it in, there it is, and I went ahead and graphed it, and I know it's a parabola. Specifically, it has, just trust me here, x-intercepts at -1 and +2. And I'm going to go ahead and sketch that on my paper right here. It's just a sketch. It's not too fancy. I know. So there's -1, there's +2, and it does like so. If I wanted more points on the graph, I could find them with an XY chart. That's a very nice sketch of f of x. All right, so this, ladies and gentlemen, is the given information. This is what I'm telling you. So the question becomes, what are we doing with this? Here's what I want to know. What is the function x plus 3? What is the equation for it? And then, what is the consequence graphically? Yeah. All right, so let's start with this. This notation here is saying we are going to do a composition. We are going to fill in x plus 3, a function of x, into our function of x. Play pretend with me for a minute, though. Pretend it was just f of 3. Wouldn't we write 3 squared minus 3 minus 2? Everywhere we see the x's, we would replace it with just a 3. In other words, it would become, instead of x squared minus x minus 2, it would be 3 squared minus 3 minus 2. That's if we were pretending, though. There's actually an x plus there. Well, here's all we do, people. In the blanks. How many? Both. All. In all the blanks, we're going to put an x plus 3. Yeah. Think it through again. If this said f of 7, it'd be 7 squared minus 7 minus 2. Well, it's x plus 3 squared minus x plus 3 plus 2. And now we're going to simplify this out. Simplify it out? What do you mean? Well, we have to FOIL this out. I am sick to death of seeing x squared plus 9. That's wrong. We have to do x plus 3 times another x plus 3. If you want to use the boxes or if you want to FOIL, whatever, we should get x squared plus 6x plus 9. If you need to pause the video and do the work, that's fine. Right here, do you see this negative? Do you? Do you see it? That negative needs to distribute. Distribute. We get negative x minus 3. And then the minus 2, bring it down. Bring it down. Simplify that out. We're going to get x squared, has no friends. These two are like terms. That's positive 5x. Plain constant terms all combined to get a positive 4. So here's what I'm saying to you. F of x plus 3 becomes this parabola. Now, graphically speaking, what does that look like? Well, once again, I have a graphing calculator. What? So I'm going to go to my y equals. Now I'm going to leave that one there so we can compare them. And here on y2, I'm going to put in our new function. X squared plus 5x, what was it again? Plus 4. And so I can tell them apart. I don't have a color one here. I'm going to put my cursor right there, hit enter one time so it'll be darker than the other one. And I'm going to graph it. So there's the original. Oh, look, it's the exact same shape, but it's moved left. 3. What? Check it out. If I take this point and move it 1, 2, 3, and then move that point 1, 2, 3, this is f of x plus 3. Wait a minute. Don't we remember that if you have a plus 3 in with the x, it changes the x direction in the opposite? If it says plus equal left, doesn't this mean go left 3? Isn't that what happened? Didn't the original graph move left 3? And isn't that what this parabola is? It's the original parabola, but left 3? That's crazy. I know. I wonder if this idea of putting stuff into a function works if it's a piecewise function. Well, let's find out. Yeah. All right, here's a piecewise function. Pause the video if you need to. And we're going to sketch this out. Come on, it'll be fun. All the cool kids are doing it. All right, here's what I spy with my little eye. It's a parabola when x is less than 2. Here's the x-axis. There's 2. On the left of 2, it will look like a parabola. X plus 1, that's a line, mx plus b. It's a line with a slope of 1 and an intercept of 1. And we will keep the line, but we will only keep it right of 2. Now, we've done this before. We can get really close to 2 here, and we're actually equal to 2 here. I like to do a little teeny tiny XY table. Here we get close to 2, so we'll use an open circle. Here we're actually equal to 2, so we'll use a solid dot. That will help us with our graphing. All right, so even though it's not equal to 2, we get really close to it. You fill 2 into this. 2 squared is 4. So we will not actually touch the 0.24, but we will get super, super close to it. Yeah. Plug 2 into this one. 2 plus 1 is 3. And our line will actually start at the 0.23. All right, so I'm going to sketch this pretty quickly here. I'm going to sketch the parabola on the left of 2, coming very, very close to, so close, 1, 2, 3, 4, that we actually put a circle there at the 0.24. And so my parabola will go left of that. And, you know, what's the standard parabola? 1, 2, 3, 4. Get some points on it. So here's the parabola, y equals x squared, but I'm only keeping it on the left of 2. X is smaller than 2. On the right, we have the line y equals x plus 1. Now, if you want to, this is a slope of 1, intercept of 1. You could do the intercept of 1, up 1 over 1, up 1 over 1, and there's our 0.23, up 1 over 1. And here's the deal. You could graph that. Sure you could. But there's a small problem. We don't get to keep all of it. What? Yeah. I could graph the whole line from negative infinity to infinity, but we're not going to keep it. We are going to keep x greater than or equal to 2. That's this side of 2. And where does it start? Well, we already did the work at 2, 3. So I'm going to keep from 2, 3 to the right. Well, what do you do with the other piece? Well, you have to erase it, and that's why I worked with pencil. All right, so there's my piecewise function. But here's the deal, people. Here's the deal. I have a question. Yeah, I do. What would we get? Wait for it. Let me get a clean piece of paper. What would we get if I call this new function, oh, I'll do it in red, k of x? Well, what's k of x? I'm going to define k of x as f of x minus 1, close it, plus 2. I know, it's crazy. It's crazy. Well, before we get into that, let's remember what this means. If you're in with the x, you change the x, but you do the opposite of what it says. It will move your graph right 1. Do you see the plus 2? Is it in here with the x? No, it's not. So what will that do? It will move your graph up 2. So without even knowing the equation for k of x, could you sketch it? Well, yeah. You take this graph and you move everything right 1 and up 2. I'm starting with the circle and then the dot, right 1, up 2. I might pick the vertex, right 1, up 2. I could pick another point on the line, right 1, up 2. And I could sketch this out, and I'm kind of moving quickly here. And this red graph would be my k of x, which is f of x minus 1 plus 2. Well, that was pretty easy. Yeah, but here's the harder part. You know how f was written as a piecewise function? Can we write k of x as a piecewise function? I think we can. Here we go. K of x. All right, let's go through this. Doesn't this mean in the f function we would take the x's out and replace them with x minus 1? Play pretend. Pretend under my finger it's a 9. Wouldn't we put 9s in for the x's? Yes, we would. So starting right here, do you see this x squared right here? I'm going to remove it. There's the square. And I will replace it with an x minus 1. But wait, don't order yet, there's more. The bottom piece is x plus 1. Instead of x plus 1, I write blank, plus 1. And what goes in the blank? X minus 1 goes in the blank. Are you with me so far? Now what about this plus 2? Well, here's what we're going to do. At the end of each one of these pieces, not in with the x. The only place you can't put it is inside the parentheses with the x or in with the x. So at the end of each piece, I put a plus 2. All right. Now what about these inequalities? Well, first of all, it's still going to be an x. It's still going to be a less than. X less than. It's still going to be an x. Still going to be a greater than. X greater than or equal to. But the number 2 has to change. Why? Well, remember what that 2 meant? On the blue graph, the original graph, at 2 we switched from the circle dot. At 2 we switched from the parabola to the line. But wait, we moved the graph over. We moved the graph right 1. Where is the red graph switching? It's not switching at 2, it's switching at 3. You moved right 1. Well, even the transition has to switch right 1. So instead of a 2 here, we put a 3. I know. Now, of course, you could simplify this carefully, foiling that out and combining like terms. Here, we don't even need these parentheses, so the negative 1 and the positive 1 cancel. We get a 2. So if you wanted to, I'll just do it right underneath here. If you wanted to, pause the video, foil it out, combine like terms. This should be x squared minus 2x plus 3 for the top piece. And down here, x plus 2. Yeah, the back would still be changing at 3. Hope you enjoyed that. Transitions.